Hello, my name is Jespersen, Solution Architect at Transmute. What I'll do today is take you through the Neo4j Adapter, which is an adapter we've built for our Verifiable Data Platform. What it does is leverage the linked data underpinnings of the credentials that you manage on the Verifiable Data Platform to populate a graph database, and what we'll do, we'll run some advanced analytics on that platform. We're going to use a single verifiable presentation, this one that includes 8 credentials, all of which have been verified. That means we can already trust the data. There's a lot of assertions that have already been done, which just makes our analysis all that more powerful. In order to populate this over into Neo4j, we're going to install the adapter that I mentioned before. So we'll go to the marketplace. And I'll fill in, I've already made a Neo4j Aura instance, and I'm putting in my credentials for that and click install. This will download a script, which we will just open here. I've already run it once here, but we'll just do it again. And I'll take this out of the way, and I'll just go to the guide. There are 2 scripts, 2 commands we need to run. One is get give it execution rights, and second will run the actual script. So it's super basic. It really couldn't be much easier. What the script does is set up a repository on my GitHub account. So once it's done, we'll be taken to my GitHub. And I'll just show you what that looks like here. And this has a workflow here that's called synchronized presentations to Neo4j. One of the benefits of running this within GitHub is that it makes the adapter fully configurable. So the default is to synchronize presentations, both send and receive presentations, but you can really tweak it to do anything. Just pick out specific credentials or all credentials. You can do it however you want. But this is default because we anticipate this will be what you'd normally often want to do. So we'll just start the workflow. It takes a bit to spin up and run, also depending on how much data it includes. I'll just switch over to Neo4j. And once it's completed, we should see here a list of the classes that are used in those 8 verifiable credentials that we looked at before. This should allow us to query for example, verifiable credentials. So if we query here, we see 8 nodes. And each of these nodes correspond to one of the credentials that were listed on the Verifiable Data Platform before. Each node we can drill into like this. And what you'll see here, if you know the verifiable credential data model, this is not all that surprising. This is the presentation that includes the credentials, so it would also have relationships to the others. There's an issuer, obviously, an organization that's issuing the credential. And there's a subject, and we'll just drill in a little further on the subject. The subject is where the data becomes more business-oriented. I'll just take these out of the way. So being an invoice, it has some items. It's got tax and payment due and charge specifications, so on and so forth. But what we want to focus on here are the parties, the buyer party and the seller party in this case. All invoices have a buyer and a seller. And we'll just look at one of these, which has a location with an address in it. So that's just an address, nothing super interesting about that. But if we look at the other one, it also has locations, but it's got something else that's quite interesting. The same organization that was the seller party of the credential apparently is also the selling party on a second invoice and the buyer party on a third invoice. That's new. That's a relationship that wasn't immediately obvious from just looking at the invoices in list view. We can obviously drill further in here. And indeed now we can see that this connects back to one of the other, if you remember the 8 blue credentials that we started from. This now links from one of those, and we link through that organization, links those 2 credentials together. That is a relationship that we wouldn't have immediately found, but because this is connected up at the linked data layer behind, which, like I said, underpins the credentials, putting it in here, such relationships become tangible and obvious. We could keep drilling into this manually, but it wouldn't be particularly efficient, and it would also, it's kind of random how we go about this. I'm gonna just zoom out instead. So what I'll do here, I'll just query all the nodes from those 8 credentials, which, you know, it looks pretty and it's quite overwhelming, but really it's only 8 credentials. In reality, this could be like thousands or millions of such nodes. Obviously, this is not for human beings to navigate this, but now we can start leveraging some of those smart tools I talked about earlier. So Neo4j comes with a graph data science library, and the most basic of those algorithms are included in this user-friendly tool. I'll just close this one up. The library has everything from basic graph algorithms up to machine learning, like very advanced machine learning algorithms. The ones here, I'll just demo the one called PageRank. And you would know that from Google. It's what drives the ranking of Google of web pages in Google, named after Larry Page. It works the same here. It ranks the nodes based on how many edges connect to them. So if we just run this and color code here and zoom out a little bit, we'll see that some of these have a darker color, which means that they have a higher score. So this has about 53%. This is the same. And here we have a little higher. But really, we were looking at parties, and this might be interesting, but these are not that interesting because these are just security. These just correspond to the security model or data model of verifiable credentials. If you know the standard, you know that all credentials that have a proof have a proof purpose and have a verification method. So really, we want to not include these in our graph algorithm. So what we'll do, we'll just tweak the algorithm a little bit. We'll look at relationships here, deselect, and only include buyer party and seller party in our analysis. So we'll run the algorithm again and apply color coding. Now you'll see that most of the graphs, most of the nodes are just have a very light color, and the ones that are colored are all organizations. And that makes sense because obviously only organizations can be a buyer party or a seller party. So here we have probably the one we looked at before is the highest ranking. This is a little lower. It's pretty obvious from when you zoom out that the Silverstone Technologies organization is the one that seemingly has the most connections with the invoices that we've been looking at. What that tells you depends on circumstances, but it could mean that's where you want to target your marketing. It's where you want to, the ones you want to make a phone call, or it could be, you know, anything else, risk assessment, or that all depends on the business context of your analysis. But what we've demonstrated here is how easy it is, because credentials on the Verifiable Data Platform are all underpinned with linked data. You can directly put it into a graph database like this. We've done no manual mapping of data in this. We've literally just pushed it over, and we've seen how data snaps together and form these graphs. And we've run some basic, but nonetheless somewhat business meaningful graph algorithms on top of them. and we've gotten a business outcome from that. So with that, I want to thank you for your time, and I'll see you next time.